go over here and make sure it's working. Okay. All right, so welcome to computer graphics rendering class today. We're going to talk about interaction. And keyboard, the mouse, or any other type of input. You normally have some kind of event that happens, and that's I'll say that that's nice. Sometimes you don't get an event, and you have to kind of monitor and watch out for something changes, and we'll see that with the gamepad. But the general idea is that keyboard and mouse are kind of well-established input devices, and people are used to interacting with them. And the kinds of, I guess, basic things that you can do as far as event-wise, you can find out when the key goes down, when the key goes up. All right. Now, a lot of times, you might have several pieces of information associated with that, like which key went down. But it gets a little complicated because if you actually look at your keyboard, like I'm looking at my laptop keyboard over here, and most of us have QWERTY style keyboards, QWERTY, and when we're typing it out, we expect those letters to show up. However, how do you get a capital letter out of that or a lowercase letter out of it? And so we have different kind of modifiers that we can inform Windows, Linux, Mac, whatever we're using, what is happening with the keyboard. So if we hit Shift and we press Q, we are expecting a capital letter. If we turn the caps lock on, we're expecting capital letters. And if we hold the Shift button down, then we're expecting a lowercase Q to show up. So we have some expectations of what should happen when these events come through, and how we expect the application to kind of deal with it. However, those kinds of things can make it more complicated to deal with because now, first of all, you have a few choices. These are design choices from the standpoint of the web browser, the operating system, and for one, how are key names decided, right? How do you come up with the with a number to identify it? I think for the longest time here in the United States, we're used to ASCII, where capital A is always 65. That's the number for capital A, and but things get more complicated because you go to suddenly you decide you're going to switch countries, go to a different country. Maybe you go to China or Japan, and now the concept of A equals 65 doesn't really have any kind of meaning initially, So those are some design choices. So then, normally what happens is that the keyboard will there'll be several pieces of information. So for one, you'll get a scan code. Anybody heard of a scan code before? No? Okay. So scan codes. So for one, this kind of comes out of the, get a marker here. Kind of comes into how the keyboard itself is implemented. Has anybody tried to design an electrical circuit? Yeah? Okay. So how would you like to design a circuit for, let's just say like the typical 101 or 102 key keyboard. How many would like to design a circuit that can identify 102 keys? It doesn't sound, it doesn't sound exactly right. So most of the time, there's actually what's called a keyboard matrix. And so rather than trying to uniquely do each key to one output, we'll do like a matrix of connections. I'm just going to draw part of this. And so now if you're pressing this key, it'll cause this circuit to light up, and it'll cause that circuit to light up. And you can kind of figure out, using a few sensors this way and a few sensors this way, which key on the keyboard is activated. Okay, so that actually makes it a lot easier to design an electrical circuit that can measure when you've pressed any of those keys on there. And so what happens is you get a scan code out. And the scan code then is what is sent to the operating system via a serial bus or something. It says, hey, this key is, or this is the status of the keyboard. And then that scan code will then be interpreted by the operating system. So there's a whole bunch of processes that goes in from the keyboard into the operating system. But by the time it gets to you, the developer, a lot of times you'll have a scan code. And this scan code will be the actual physical key on the keyboard. Okay. Now, there's no, I guess, necessary guarantee that the scan code is portable. So in other words, if you're developing things on your PC, you could probably depend on the scan code not changing. But then, and probably for a number of PCs, like if you just stick with Windows and all you ever do is Windows things, that scan code probably won't change for you. But you go to an international, you have a different manufacturer of the keyboard or something, and maybe a different PC or something, the scan code could change on you. In other words, you can't necessarily depend on the scan code being the same. So in other words, Windows might report the scan code as being something, and then Linux might report it as something different. Depends on how the operating system wants to interpret these signals. It's kind of driver-based. And normally what happens is that scan code gets translated into the key. Okay, so to some kind of constant. And that can depend, and this is so that now as an API developer, you have something that you can work with. So for example, on Windows, a lot of those constants start with VK, which stands for virtual key. And so it might be like virtual key F1, virtual key F2, and so on. And so then you can, if you're a Windows developer, you're like, all right, I can check to see if this was the Windows, if this was the F1, the function 1 key. So then you can go ahead and check that. But then that number is not necessarily the same. Well, for one, you don't have this set of constants on a Unix computer. It's different. So then you have these cross-platform libraries like SDL, LUT, GLFW, you name it. There's several, and they'll have like their own set of constants that will basically, you can use those then to, so now your applications kind of get unwieldy with all the number of keys that you're doing. So most of the time you need to have some kind of layer that does a little bit of interpreting for you. The operating system normally gives you several different, I guess, phases. So they'll translate the key. Most of the time there's a way to get what the Unicode key value ought to be. So this is the value that would go in the string that you would save to a file. Okay, but then the problem there is that what if you have capital A or lowercase a, then so you have a bunch of, in your program, you're basically writing, okay, if the capital A button is pressed and if the lowercase letter A is pressed, and that's normally what you end up seeing when it comes to keyboard input. Okay, so that's kind of the practical way of doing it. Now, we're doing everything in JavaScript, so thankfully that kind of gives you a cross-platform standard way of referring to these, but they use strings to kind of identify the keys, right? So you'll get like capital A, lowercase a. What's nice is that the F1 keys and so on, it'll be like F1, F2. I want to say arrow left, escape. So some of these other more difficult keys, you can look at those key down events, key up events, and you can compare them to these strings, and then you can check for things like the arrow keys, page up, page down. There's a lot of standard ways of looking at that. Okay, and so so there's a few. You can read up on this type of stuff, but this is some of the complexities that kind of go into using the keyboard for input, and that is you normally have to just be comfortable with looking up what the key characters ought to be. Okay, and then you'll have to apply the status modifiers potentially if you're trying to do something with it. So if you're trying to look for shift, control, alt, or meta, and I use meta. That's one way of referring to like the Windows key or the Apple key. I don't know what that symbol is called. I think it might be called meta. But and then sometimes if there's extra keys on your keyboard, then those will have other, then you start getting more specialized. So you also have to be careful with just arbitrarily choosing whatever you want for a key configuration, because that doesn't necessarily mean it's going to be useful for everybody. So one of the, for example, who's heard of WASD? WASD. All right. If you played most or just about any kind of many video games, first-person shooters, they all have this standard WASD, which if you look on your keyboard, that just happens to be shaped the same way as the arrow keys. So it's a good way to have arrow keys for your left hand. So WASD is just basically the same configuration. You use your left hand to go up, down, left, or right. Okay. However, that's not necessarily the same. That doesn't apply to everybody. So if you were to go to France, those keys on the keyboard are not laid out that way. So inadvertently, if you say, I'm going to hard code in WASD, then all of a sudden somebody overseas can't actually play your game correctly because of the, I want to say that Z is in the same place for A. I think it's like, let's take a look at that. Keyboard layouts. So there's WASD, but there could also be I want to say European. QASD, that's another one. Here we go. ZQSD. So this is a AZERTY keyboard. So we're used to QWERTY keyboards, but an AZERTY keyboard, they might have ZQ, S, and D instead of WASD. So you might have to swap, check Z's in addition to W's, check Q's in A's. Then it complicates other things because sometimes it's also nice to use those neighboring keys up there for different operations. We're going to look at that. Maybe a little bit how I use them. Okay, any questions so far on the keyboard? Okay, so the second type of device we might want to use is the mouse. So the mouse is also like the keyboard. We have events that help us to use this. So these are typical events like on mouse move, on mouse down, or the button down, button up, wheel up, mouse enter, mouse leave. Sometimes the wheel is just one control and just tells you positive or negative which direction it went in. Sometimes the wheel down, wheel up, those are buttons 4 and 5 on the mouse. So you might, if you're getting input on a scroll mouse, you might see buttons 4 and 5 light up if you're going up or down. Or you can have that, and then of course if you hold down a It acts like a middle mouse button, so mouse button 2, I want to say. Okay, and the kinds of motion that we're interested in are position and relative motion. So in other words, sometimes you want to know where is the mouse exactly, like where is it on the screen. The other part is, well, just how much did it move by? I just want to know how fast the mouse moved. Okay, so the operating system will normally report X, Y. Sometimes it'll report a delta X and a delta Y for you. You also have to consider, well, what kind of mouse am I supporting? Because I figure nowadays mice are more complicated than they used to be. But for a long time, there was the classic 2-button mouse that you would see on an IBM computer, and there was the 1-button mouse that you see on an Apple. There was no right click. There was just the one. It was like the ultimate in simplicity, one mouse button. And then if you wanted to kind of modify that, then you'd hold down like the Alt key, the Option key, and then click on the mouse button, and then you can interpret that. So you can combine your interpretation. What is the keyboard doing, and what is the mouse doing right now? And you can use that to interpret what action that you should take. Okay. So if you think about it, the mouse is a little bit more complicated than the keyboard, because the keyboard normally you set yourself up an array or a map. You can set up a map. So one way of thinking that, I'll just use C++. You might have a string or an integer, but if you're doing HTML, strings are probably easier to use. So a string and a Boolean. Although one could argue maybe you want to use a floating point number for that, or a integer. And why would maybe we want to use a more detailed type for this kind of information? So this way you could say, if keys okay. So if you're handling these events, you may want to have say keys, right? And then you just set it to true if the button's down, false if the button's up. That way, when you're going through your update loop, hey, if that button's down right now, we're going to do this. If that button's not pressed, we just ignore that. But over here, maybe what would be some advantages to picking a different representation?
Like a gamepad, you have like multiple states for your button. Like if you on the trigger buttons, you can pull it just a little bit or more.
Right.
Values.
Yeah. Pressure, right? I'm gonna try and draw a picture. I don't know if it'll work. Okay. Somebody's fingernail. There's that. You might like apply pressure to it. I think I remember the PlayStation 2. It's kind of interesting because it would actually have pressure sensors on the buttons. So if you were like doing a racing game, if you held that button down harder, which people were doing anyways, if you really held that button down, it would do a little bit more than the normal, because it's not reporting on off, it's reporting 0 to 1. So if you're really pressing hard, maybe that's like you pressing harder on the gas pedal, right? And so that was a way of, so if you lightly press it, then it's just like pressing the gas a little bit. And if you really press it, it's like putting your foot down. Whoops, banging around over here.
Have other controllers passed or after the PS2 implemented that, or?
I think so. I don't have my Xbox controller here right now, but even the HTML5 API will report 0 through 1 for the button values. Okay, so that's a very common thing, is to be able to measure pressure. So how much are you pressing it down? And it makes the controller more, you can do more, I guess, more responsive to how you're using it, which makes sense, right? I mean, people, like I said, people are already like, you watch kids play and you'll see them, it's like, man, take it easy, relax, it's just a game, but some people just like, they're holding that thing and they're going crazy. Okay, so there are some useful, there are some useful use cases for using values other than Booleans. Okay, and the nice thing about it is if you set it to 0, I mean, it's going to act like a Boolean value anyways. So if it's 0, then it'll be false anyways. So there's really no disadvantage to doing it that way. Okay. All right. Now, kind of talking more about the mouse. It is a little bit more complicated to deal with it, because when you get these events, you're getting, okay, the button is down, right? And let's just say that you want to handle events like a click. I'm going to erase this real quick. I'm going to move some of that down. I'm WASD or ZQSD. Right, so I mean, let's think about this. How do we expect click to work? The click action. What kind of sequence of events do you think? Is a click just you putting the mouse down? Pressing the mouse button down? Is that what a mouse click is defined as? Or how would we define a mouse click?
Trade things when you put the mouse down, usually depending on the context.
Okay, so we might actually want to support dragging. That's a good one to put down there. Drag. Okay. So we can't just have a mouse down event, right? For click. So what else do we have to have besides just mouse down? Mouse up, right? Okay. So we have to have mouse down and mouse up. What else about that? For a click. What if you move the mouse? Should that change if a click happens? So if if you suddenly, move over here, when the mouse button goes down and then it goes up over here, does that count as a click anymore?
You need a...
Or does that count as a drag?
You need to keep track of mouse position X and mouse position Y.
Yeah. So you gotta keep track of that. Okay. So so one way of so that's something you have to think about, right? If you move the mouse, does that count as a click anymore? Maybe it doesn't count as a click anymore. Okay. The other one, I guess the corresponding one, is then a double click. How does double click get more complicated?
You have to have a sort of timer or something before you stop counting or checking for a second click.
Right. So you have to looking for mouse down, mouse up, mouse down, mouse up before it counts, and you're checking with if that second up happens within a certain time. Okay. And then you have to check, well, did the mouse move, right? So how many people have seen people struggle with trying to double click a mouse?
So
just watch like a 5-year-old try to, like, the mouse is moving. It's like, no, you got to keep the mouse still. And they're like, it's going or people who've never used the mouse before. They're just like, this is strange. What do you do with this thing? Okay. So yeah. Okay. So there are some interesting things. There's maybe a drag. Maybe you don't want a drag to happen if it's only been a short period of time. Maybe you don't want. This all comes down to like what counts as a click. Other things too is it depends on the control you're using. So a lot of times with graphics, is there anything, I guess your personal experience so far, anything on inside the window that we draw the graphics? I mean, any support at all for things inside of it, like you want to click on the teapot, or you want to click on the bunny, you want to click on something you've drawn in there. Is there any support for, if you have a picture, right? You've drawn a picture of 2 squares, or rectangles. I mean, is there any like notion of I clicked in this spot, or I clicked in this spot? Not really. In fact, not at all. It's just, when you look at these events, they're just like, okay, the mouse was clicked at this portion of the window, and it's really up to you then to decide, okay, well, was the mouse inside over this object, or was it over this object? Okay, sometimes we'll call that picking. In other words, this is a problem. How do we determine what we were over inside of a canvas that we drew, a frame buffer? Okay, because that's going to be important for interaction. Sometimes we don't really care. Like we're just going to go ahead and maybe we just want to move an object around. So we're just watching for windows in the main area, but sometimes we'd like to be able to select an object and then manipulate it, right? Okay, so this is just to kind of illustrate that mouse events are a little more complicated than the keyboard, although the keyboard can be a little more tricky. Depends if you're trying to write a control where you can type into it. But that's I think that the keyboard is probably easier to write code for than the mouse. Although there are some useful things we can do with the mouse. So we're going to try and work on those today. Any questions so far on the mouse? Okay. Gamepads. Okay, so gamepads are different in that we don't get events for gamepads. There's no event that a gamepad button was pressed down, or that was released, or what the current value is, like we get for the mouse or the keyboard. The way that the gamepad works is that you have to poll for the current values. What do we mean by poll? Or polling? What do we mean by that?
We have to check it every time we want to know something.
Right. So we want to check it every single time we need to know the current values. We have to go read the current values. Now, what problems might show up if we do that?
We're checking it every frame, and our system's running really slow. We're also checking it really slow.
That's correct. Okay, so so in between the poll, if somebody were to press a button and then release it, and then in between this poll, it never happened, because according to your poll, you just read 0 the whole time. So you assume that 0 happened the whole time. Okay, so the frequency that you poll is going to affect how fast that the response is going to feel to the player or the person using it. They're like, hey, I'm pressing the button. It's not doing what I. And it could be you ever see somebody get frustrated with an input device and they're just like engaging with it more frequently, like it's going to do something more if they do. That's probably even going to cause those problems to happen even more, because those button presses are going to be like quick on off, on off, on off. And if you're not polling for those, sometimes you might get it, sometimes you might not. Okay, so polling frequency is going to affect that. I guess if you have a way to control, and this is a challenging part, because sometimes your graphics and your input are all happening in the same thread of execution. It can be hard to separate the two. So that's something you have to keep your eyes out. How frequently do you poll? And so a lot of times, the only way sometimes to make input feel smoother is just to make the graphics experience more smoother, so you're not having frame stuttering happening and everything. So you can get to that polling when you need to. Or sometimes you might need to poll while you're doing your graphics rendering. If it really is a problem, you may need to add spots where you poll for input. Okay, so hopefully the things that we're doing probably won't, I don't know. Simple is better. So the simpler the things you work on, the more likely it's going to be to just kind of work out. Okay, so gamepads are different than, they have their own unique attributes to it. So you have this concept of axes and buttons. What do we think the difference between the axes are and the buttons?
Axes aren't on or off. They're some range of value.
Yeah, they're like an analog. They represent some kind of analog input. So if you imagine like a joystick that you're moving, that's kind of where that whole idea comes from. Okay, you have your stick axis, so x-axis, y-axis. So we'll call it axes, plural. Okay, gamepads though are more complicated than they used to be. So you'll have normally a left stick. So if you have for the left thumb controller, you have a right thumb controller. Okay, if you have joysticks, those are going to obviously act differently. Normally, the left stick on your controller is considered basically axis number one. You can buy some advanced joysticks that have even more axes associated with them. Different analog controllers. I have one at home called the Hotas Cougar, which is this set of joysticks here, and there's loads of buttons on here. There's extra sticks, and that moves up and down. They got knobs on there that you can twist. It's got a lot of different things you can do with it. Okay, so that is going to be depending on there's a certain interpretation that goes along with, well, what does the left stick mean? What does the right stick mean? What if you have 6 sets or 7 axes that you're dealing with? So sometimes on a gamepad controller, the shoulder buttons will count as sometimes 1, sometimes 2 axes. So the Xbox controller is kind of unique, depending on if you're using its built-in library or not, because it represents one axis. They call it the Z-axis. So you have X and Y. But the idea is if you press the one, that goes positive, and if you press the other one down, that goes negative. So, and then they just sum together, right? So if you're pressing them both down, you get 0. Okay, so the idea is that if one's a brake and the other one's gas, then they should cancel each other out. Okay, so it's kind of interesting how that works. So there's gamepads it's one of those things that you think it should be more standardized than it is. And so it's tricky sometimes to get gamepads correct, all right? But you can do a lot with them. They're definitely fun to work with.
For the Xbox One controller, the button numbers, each button is numbered differently depending on your operating system.
Yes.
Mac, it's like, I think, starts at a different index. Not different index, but a different number on the right button pads. Kind of confusing, and the sticks also have different numbers too, I think.
Right. Well, this is, I mean, there's a Super Nintendo, right? You have B and A, Y and X, okay? And that's pretty much normal on the Nintendo controller. But then you go to the Xbox One controller. You'll know what I mean. A, B, X, Y. They're flipped, okay? So you can't just make assumptions. And then, of course, the PlayStation, there's, you know, you got X, O, square, triangle. And so most of the time, thankfully, they're mapped kind of smart. So this button down here is 0, this one is 1, this one's 2, and this one's 3. That's pretty much standard. Although if you make the mistake of buying talking to you, these off-brand controllers, man, I think I bought one of these off-brand controllers, and it's not even like the correct numbering. Like, this is not 0. I mean, it's awful. And I was like, I can't believe I wasted $15 on this, because the controller is like, it works okay if you're gonna. Well, first off, they're built cheap, but the second thing, you go use it on an emulator, you're gonna play a game, and then it's okay because you normally have to map your buttons to the action. Okay, so that's one big aspect to joysticks. Sometimes if you're writing it, especially native applications, you may have to have some ability to say, I want to remap my key. Okay, so and that's, everybody has preferences. So you can either try and just say, well, I'm going to implement a fixed, this button always means this, and if you don't want to play with my rules, then that's okay. You don't have to you don't have to use my application. Okay, and depending on, so I mean, the idea there is you want to try and stick with research, find out what's normal, right? If you press the main button, what should that do? Should that exit the game? You know, there's norms, right? So gamepads, mice, keyboards, you just have to kind of study how things are used so they feel familiar with somebody's using your program. Anybody try to use a program that use non-standard controls? And okay, and
Any old PC game.
yeah, you go back, you play some older games, and they're all different. Okay, now feature for this, but what key is this? It's happened to me numerous times, you know. So I mean, over time, you just kind of get better and better. Like, okay, I'm gonna just use this key for this or that key. But yeah, if you spend any time with your own programs, you're like, I just need something fast. I need to test this feature out, and then yeah, you forget. You forget to document it, and then you got to dig in the source code and find out. That's bad when your source code has to be the documentation for how to use your program, you know. But that happens too, right? You just forget how to use your own program. Okay, so yeah, so there's gamepads. Okay, so I put in a few links here. A lot of the other mouse events you can get to from the just by clicking, you can see the related events there. But so let's take a look at key down real quick, because I think that would be useful. And so this is you know, in JavaScript you have a bunch of events, and we're going to take a look at some source code here in just a bit. But you'll see over here that there's like key, which is a string. So this is let's go ahead and look at this table here. Thankfully, even though the Firefox browser isn't as good as it used to be, they have really good documentation. And so you have a few events, key down, okay, auto repeat handling. It tells you what you should expect these events to come down as. Okay, browser compatibility. Okay, so this is good though. If you decide that you're going to do anything in JavaScript, check to find out what browser it's going to work on, because it could be that you're like, yeah, key identifier, and only works in Safari, and if you only develop on a Mac, you're thinking everybody has this feature, you know, and that might not be the case. Or it might be that the web browser only started implementing it like in like this one is over here, version 28 of Firefox or 31 of Firefox. So some of this stuff has been around for a long time, and then some of this stuff has not been around at all for any length of time. So if you're relying too much on new features, then that's dangerous, because then not too many people can use that feature. But this is important to know. So you have a few flags here, like the Alt key is the Alt key pressed down, the Control key pressed down. These key codes, what does that mean? Some of this might mean non-standard, expect poor cross-browser support. Deprecated. And as soon as a new browser comes out, they're like, nope, we don't use this one anymore. So let's go down. Let's go to keyboard.key. Predefined key values. There's unidentified. That one's, I guess, good. Virtual key code. So remember what I was saying earlier. Everybody has different numbers for what each key means. Okay, so when they say virtual keyboard, Windows, Mac, Linux might not be the same thing for, and that's just for unidentified keys. But like the modifier key, so Alt. So if you look at the .key value, this will be Alt. So you can check to see if key Alt is set. So on Windows, right, VK menu, it could be VKL menu, VKR menu. Those are the virtual keyboard codes on Windows. If you're on a Mac, these are you'll see over here that the option and the right option buttons, this is value 3A, and this is A4, and this is 3D, and this is A5. So there's not even the same thing at all. On Linux, looks like we have a 16-bit value over here for Alt left and Alt right. And that's definitely not the same thing as those. And then on Android, 57 and 58. Okay, so you cannot depend on, and this is why I think they're getting rid of key codes in the browser, just because, I mean, they probably will support them indefinitely because it's part of something that was in there before. But it's better, I think what they want people to use the standard way of checking the value. Let's see if any of these do match. Control, nope. Some of these keys don't exist. This one exists on a Mac, and Android doesn't exist on Windows or Linux. The hyperkey, I guess that exists on Linux. Meta, so that's like the Windows key or the command key, meta key. Those are all different. The shift key, A0, A1, those are all different. Okay, so this is just be happy you're not working on the browser source code. Somebody implements a new operating system, and now your job is to write the code that says, if this scan code, then this should be this HTML key. Okay, white space keys. Enter. So this one is browsers. You may have to add extra checks. Okay, then there's arrow down, arrow left, arrow right, arrow up. This is kind of interesting because some browsers will just will be okay with like down, left, right, and up, and then other browsers don't even accept that at all. So that could be a very, like if you test it out in Edge and Chrome, it'll work, but then you check it out in Firefox, it won't work at all, and you're like, how come it doesn't work? And so anytime you're doing keyboard input, you have to check several browsers, make sure it still works with those browsers, because you may have just hard-coded something that isn't portable. Okay, editing keys, all sorts of stuff there. Okay, so documentation is worth reading. The Gamepad API is not too bad. Looks like they got some experimental stuff. Oh, so if you have WebVR controllers, that's going to be a new thing too. That's like a different concept. Okay, but what's nice, you can call this navigator.getGamePads, and that will give you the gamepad objects. And then there's two events. So if a gamepad gets connected or disconnected, you get an event letting you know that it's on or off. Okay. And then there's a tutorial for how to use the gamepad API. All right. Okay, so any questions so far looking at documentation for JavaScript in terms of window events? There's a lot to explore there, okay? You really get a good feel for all the details you need are there. Okay, so let's talk about types of interaction, right? So what if you want to move objects around? You have to ask yourself, that might be your use case. You're making software. Somebody says, I want to be able to move the objects around. Well, what does that mean? Okay, so let's think about this problem. If I say I want to move objects around, what does that mean? Like, I always like to think of, how do we get from a qualitative description, right? Because if I say move objects around, that might mean perfect sense to me. But what does that mean? Move objects around kind of implies, we're talking about interaction, okay? So let's think about it from this standpoint. We have input, output. So what do we think we mean by input when I say we want to move objects around? What do we think? How are we going to take? What are we going to use to control how that works? Input manager. We haven't quite described what that is yet. Like, we don't know what that is. So let's be even more primitive. Where does it even come from? Like, what are we talking about? Input from move objects around with what? Okay, then we'll do that. So mouse clicks. Okay, what else might we want to use? Move objects around.
Use some sort of on-screen display where you can click on a left arrow or
oh, okay. It's like a widget.
Yeah.
Oh, what did you say, widget? Okay, that's probably good for right now, right? So this tells us exactly what are we going to be looking for. Okay. Now, output is what are we trying to change that's going to make that look like it's doing it. So we're not thinking about what I'm not asking, the question I'm not asking, or the answer I'm not looking for is the screen, right? We're not. Okay, because this is it's like the earliest step before they even get a chance to get drawn, that controls where they're located in 3D space, okay? It doesn't really happen before that, and doesn't really happen after that. Okay, the transformation matrices. So when we're talking about interaction here, moving objects around, okay, we've reinterpreted the question as, okay, we'd like to look for these types of things happening, and when these happen, then we're going to update some transformation matrices. Okay. Now there might be some other details that we might have to think about. What might one detail be? Because we have more than one object here. So I guess which transformation matrix are we updating?
you have to have some sort of like active object that shows we're only transforming one or the group.
Okay. or a group, right? Like you mentioned. I guess, is that known? Do we know which group or object that is yet, or is that something that can be controlled by this aspect? Yeah, I mean, that might actually be an output, right? Okay, so what is the active object? It could be that we don't care. We have one object in the screen. That's all we want to look at. But it could be you're writing a 3D modeler. Now you need to be able to select a different object, or maybe you need to select more than one object, right? Okay, so move objects around. Okay, so that is a different type of interaction. So here's a few different kinds that might be interesting. So one is an orbit. So we have an object. We'd like to look around the object. Okay. Now there's two ways of looking around an object. One is just simply change. If it was a ball, then suddenly like it's tilted on its side, and you're like, how do I get it back if the north is still pointing straight up and down, and you're trying to manipulate it? Okay. So that can be a problem. So sometimes the orbit, where you just say, well, I'm going to use the left-right drag operation to change the azimuth. So in other words, how far is it rotated this way? And then change the inclination, okay? And then how far am I zoomed in or zoomed out? So let's see if we can't implement something like that today. But the other kinds you may want to do, like FPS, so first-person shooter type, or maybe a flight simulator, where you use the WASD keys and the arrow keys and the mouse, right? So you may want to use WSAD for moving forward and backward. Q and E kind of neighbor the W key, so sometimes that's not. I like to. You can use those for anything. I like to use them for roll. So sometimes you're moving around, and just the process of, if you're turning and you look down, now suddenly you start spinning this way because of the way that you're rotating. So sometimes I like to do rolls so you can kind of move yourself back to where you'd like to be. That's if you have too many degrees of freedom. First-person shooters normally limit, like you can look any direction that you want, but that doesn't mean you move in that direction. So it's actually a really controlled way of keeping you from getting that roll problem that can happen by just, you're never in a position where that actually happens. Okay, so you might have a different, you may have to separate the direction you're looking in from your movement matrix. So your movement matrix might only be a fixed. We only go by the position you're at, and then your look at is a different angle, and then you combine those two. You keep them separate so they don't create gimbal lock, where you lose degrees of freedom because of down. And then left and right could be yaw, so yaw left and right. Oh, so you have yaw, pitch, and roll. Okay, and then 2D platformers. If you're just doing a keyboard, maybe you want to use a gamepad, you want to let somebody use a gamepad, but maybe you don't have access to that. So you can just say, well, let's use the WASD keys or the arrow keys, and then allow them to press space, enter, or escape to kind of go back to a menu, or start the game, or fire the jump. Maybe you have to add extra controls for, are they running? Are they just walking? So you can kind of make the control scheme as complicated as you want. Okay, and then lastly, just quickly talk about state machines. So we looked at when we were looking at the mouse events, we were talking a bit about when the mouse clicks go down, when they go up, what's a double click, what's a drag. And in order for that to all be kind of consistent, you have to kind of know, is the keyboard being pressed right now? Or I mean, is the mouse button being pressed right now? And that can go. You may want to have certain like state machines. So let's take a look at that real quick before we talk about like the menu. So this is you have a GUI widget that you're trying to do, that you're trying to write code for, right? And you have the mouse. Somebody presses down on the button, but then they move their mouse off the button, and then they release the button. Okay, so they press down on the button. They press the button, the mouse button down when they're on the button, and then they let go off the button. Now, should that button be pressed? Like, do you call the event if that happens? You have to keep track, right? You have to keep track of what's going to happen. So, who does not know what a finite state machine is? Finite state machine. Or do we need a refresher? I don't mind doing a refresher. Right, you get these little diagrams, like maybe you call this Q0, all right? And this is the start state. So there's no mouse button, okay? And maybe you go to this state if you're entering the if the mouse is suddenly over the widget, so we'll call it enter. And maybe you go into, we'll call it Q1, okay? And you leave, we'll just go back here, all right? So you can kind of go back and forth between these two states. If the mouse is over the widget, then you're in Q1. If the mouse is outside the widget, then you're in Q0, okay? And then maybe we go to another state, Q2, if there's a mouse click. Okay, so the mouse button is down while we're over the button, right? We're holding the button down, and now we're going to release it. So we're going to get our mouse click. Okay, so then if that happens, then maybe we go to Q3, and we'll call that an accepting state. That's when we call, hey, the button got clicked, go ahead and do this event. Go ahead and do that action, right? That could be the save button, right? So if we get to this point, we've entered, the mouse button got pressed, it got released, go ahead and call your save action, okay? Your callback, or whatever you want to call it. Okay, but if you leave, just erase this real quick. But if you, let's just say, then the mouse has left, maybe you don't want to cancel the fact that the mouse button is still pressed. Okay, unless they unpress it, so the mouse button goes up. However, if they suddenly move the mouse back over the button, then you go back to this state. Okay, and so now we have like a state machine that says, how should we handle the, whether or not if we press a button that it does something. Okay, so let's take a look at that. We'll use the refresh button here. So I'm over the mouse button. I'm over the refresh button. I hold down the mouse, and if I go off, right, I can still go back on it. And if I let go outside, then nothing happens. Okay. However, if I then go back on it and I let go, then we have the save thing. And this is a common way of doing that mouse action, right? So this is just one example of a state machine. And same thing could happen over here, where do another state machine. Maybe you start your game. Say let's prepare for the game competitions. You start your game. Let's say you're program is initialized. That's where you start out. And, so the one game screen. And then after that's done, then you say, okay, game's over. Let's go all the way back. Go back here to the main menu, and that kind of controls that loop. But what happens then if you lose the game, right? So maybe you lose the game. You go here to Q4. This is lose, and so this is the try again screen. Okay, and then once that's over, then you go back over here. Now, let's just say you want to make it a little more fancy. Let's add some options. So maybe you can have like an options menu. So we'll call this Q5. So options. And then you can make some changes, and then you can go back. Right, so use your back, whatever you decide your back button's going to be. And then quit, right? You could probably quit. So maybe this is not really applicable for a web browser game, but that actually could be an action that happens if you're writing a native game or something, right? Exit the program. Okay, so this is not so bad, I think. Not so bad, but is there any what features are we not putting in there that might be obvious? Like a modern game should probably have this feature in it, or maybe even any game from the 1980s. So you're playing the game. Suddenly, your mom says, "Hey, go empty the trash out." Okay, that's like every kid's lifesaver, okay? And every parent's like, I'm sure the parents screamed at, hey, you got to do something. If I need to tell my kid to go empty the trash out, that needs to get emptied out now. I don't want to punish him, right? Okay, so every game, we're getting a game, and you just hate the way the controls work. I wish I could change my controls. Now, this is where it gets more complicated, because you'd like to go back over here. Okay, you'd like to go over here to the options menu. But, so maybe you press the start button or whatever the key, whatever the case might be. But now if you hit back, where do you go back to? You go back to the main menu, and now you're no longer in the game anymore. The only way to get into the game is to start a brand new game. So how do we deal with these kinds of issues? So that's where finite state machines start running out of steam. Okay, because unless you want to have what's called a non-deterministic finite state machine, in which case you could say, well, I'll just roll some dice for you. Maybe you go back to the main menu. Maybe you go back to your game. That's not realistic. Nobody would ever do that. So this other one here, it's called the push-down automata. And there's a way, like you could have like a stack, right? So we could say we have some, maybe we're in the stack. And then when we go into the game, we push game onto the stack. And now if we're inside this one, then we can say, okay, if the top symbol says game, then we go back here. Okay, go back here. So if the stack says game and start button got pressed, then we go back to the game. And if the top symbol says main menu, then we go back to the main menu. Okay, and then if the game quits, all right, if suddenly you win, then you would pop that symbol off the stack. Or you have some other in-between status, and then you can like get rid of that, then you're back at main, and then if you pick options, you can go here, main's still on the stack here. So you kind of keep track of what your main, whether you're in the playing a game right now or whether you're in your main menu. Okay, so that's another part of interaction, because a lot of applications have modes, and you want to keep track of, as soon as your program starts getting more and more complicated, then you need to keep track of what's happening. I did a game not too long ago where it was for Ludum Dare last year, and the theme was combine two incompatible genres. So I basically combined an adventure game with a side scroller game, and so every so often. Okay, so let's take a look at some code. Any questions so far on any of this material? Okay. So let's go. I think I got it right here. Let me start the light server. I did some refactoring, so hopefully nobody's things got broken. Can never tell. But so here's the gamepads demo. So in this demo, we can use the controller keys, the keyboard keys, to move the Godzilla sprite here around. And if we look at that, just so you kind of see how it works inside the libxor library, and we go down here to number 12. The update function. I'm going to show you a little trick here. So, not using that. So xsort.input.checkKeys is a function that you can call, and you pass it an array of things that you'd like to check to see if they're down or not. Okay. So over here, I would like to check the arrow keys and the A key and see if those are pressed, or the right key, up key, down key. Okay. So I can basically say, okay, if any of those keys are down, then I'll know which button is basically pressed. Same thing, like so B0. I'm just kind of trying to pretend what I think a gamepad looks like. Okay, so B0 is the space key. B1 is escape or escape. I'm just thinking if you press that kind of corner key on the gamepad, that's like back, get me out of this. Then the control key, that could be like pressing a fire button, and then enter could be, I don't know, whatever I want. So over here, this is I find that this is a very common pattern. You want to move in a direction, but you're checking to see if left or right is pressed. Okay, so if you do it this way, if left, right, then you're like saying, okay, then so that means you're going left. Then you're checking right, and now you're going to go right. So if you have the right button pressed down, it doesn't matter if you press left or not. You're only going to go in one direction. Okay, so you're like, okay, got to fix that problem. You could either say if left and not right, or if right and not left. Okay, or you could say if left and right, dx equals 0. You start getting all these if-then statements, like rapidly increasing. So I noticed that this pattern is, well, if you just add or subtract 1 or positive 1. So like I check over here, check the left keys, and I say, okay, this dot left right equals, so subtract 1 from it. It starts off at 0, and then if the right key is pressed, then I add 1. So what happens if you're pressing left, it goes down to -1. Then if you add 1, if you're pressing both keys at the same time, then it just goes to 0 and nothing happens. And I found that's a very easy way to like avoid all these extra if statements by just kind of adding and subtracting 1 from what you expect it to be. Okay, and it basically does the same thing as checking if left and right, because then you you don't have those extra issues. Okay, so over here, and then over, so in the example here, we can check if the arrow keys are pressed or if any of the buttons are pressed. So if any of the buttons are, like if I press the space button, that's kind of like jump. So I can move around. I think that just resets the position. Okay, so there's that. And then if you have a game controller, I do the same thing because I'm using the same variable up, down, left, to right. And so I can just basically add extra inputs. So if you're using a gamepad, you could also add, you could use the keyboard or the gamepad at the same time. And you're not trying to check if left and the gamepad left is pressed. You know, you have all these extra if statements that start getting out of control. And then what you can do then is at the end just squash it so you never go more than -1 or +1 at a time in either direction. Okay. Now there's also so I can set the event. I can say on key down equals, and I have a method in this class called on key down. So I'm basically saying, okay, add my own callbacks to the window, so it always gets my user input. There's the poll, so this basically just copying the information if any of the gamepads are correct. Capture mouse, this is adding events, so I could have added on mouse down and on mouse up to the window, but I don't want to do that. I want to add to the canvas so that if I'm clicking somewhere else in the window, it's not just causing events to happen outside the canvas. Okay. You can kind of check keys over here. All this is doing is just looking through that entire array and see if any of them is pressed. And if as soon as it finds one, it just early outs and quits. So here's on key down. Now here's something that I do, because you can basically say if you press a button, then I can tell the browser, okay, whatever you were going to do with that button, don't do it anymore. And that's important because if I wanted to, I guess, press up and down, like if I want to use the arrow keys for controlling Godzilla over here, if I don't prevent the default action from happening, what's going to happen if I press down or up in a web browser? I'm going to scroll the window, and then that's going to be like, no, that's going to kill it, you know. So you can basically tell the web browser, okay, don't worry about the rest of this. But then what happened is I wanted to like go into debug mode by hitting F12, and so what was happening? Nothing. I have to go to the menu to go into the debug mode because I was basically saying I want all the keyboard input, and then I was like, well, this is a pain, you know. So so I basically added, okay, if it's the F12 key, then just early out and let the web browser determine what else it's going to do with the F12 key. Okay, so if you press page up or page down, yeah, it should keep all that stuff from doing anything. Okay, so let's try and use the mouse real quick. Okay, so let's go to maybe we want to use the we want something with I'll try not to get lazy over here. So we're going to add the azimuth and inclination. Let's set those, if I press space, let's just set those back to the defaults. Otherwise, let's go ahead and right. Let's see what happens if we just use the XY position to control the orbit. So right now we're rotating. So I'm going to duplicate this line. We'll save the old rotate, but okay, so now when this reloads, we should be able to cause this object to rotate just by moving our mouse inside this window. Okay. Wonder why nothing's happening. So let's go ahead and debug this. So we'll hit F12. Didn't like that. Okay, we'll let this keep going. Wonder if we're not capturing the mouse input. Oh yeah, okay. That's a problem in my code. I forgot to call. Oh. Oh, okay. Mouse. That's okay. Refresh. Positive 90 degrees. So technically this is like 0, 0, and then so we're going from 0 to 90, and now we're going the other way around. Okay, so you gotta check your input values, see if they're working out correctly, and so on. So next Tuesday we'll work on getting that so you can just like hold the mouse button down and then drag it so we can interact with it in a way that we think is useful. Okay? So go ahead and stop the